All right, chapter 3. Matter and energy. So let's think of an example to kind of tie in together matter and energy right away. So what happens to an ice cube when you place it in your hand? So let's say it's a really hot summer day, or you're just feel like grabbing ice out of the freezer and putting it in your water, your iced tea, whatever, and you take the ice cube and you put it in your hand really fast so that you can then transfer it to your glass. So what happens to that ice cube when it's in your hand if you don't really move it right away? Well, your hand is warmer than the ice cube. So the ice cube would absorb some of that heat from your palm. Let's say this is your palm. And begin to melt. So everything around us involves matter, and almost everything we do involves energy. So we already discussed how chemistry is a study of matter, and how matter is anything that has mass and occupies space. So matter makes up all things that we see, such as water, wood, plastic bags, clothes, shoes, etc., just like some of these pictures down here. The different types of matters are classified by their composition. So matter is like the book you're using, the screen that you're looking at, the pen, etc. Then depending on if they're made up of one type of thing or multiple things, we classify them a little bit more. So we classify matters into two categories. Matter can be classified into pure substances or mixtures. Oopsies. So, pure substances. Pure substances are a matter that has one fixed, definite composition. So basically, notice helium and pure water. Helium gas is made up of only helium. So that's matter that's only made up of one definite composition. Water is only made up of pure water, only one type of composition. So that's still matter, and we classify that as a pure substance. The other classification is mixtures. So mixtures are two or more different substances physically mixed or chemically combined. So for example, if you have a cup of coffee or tea in the morning and you place sugar in that, you mix that together. The sugar dissolves into the water. You can't get the sugar back, or into the tea or the coffee. It's chemically combined together through heat. If you put sand and water together, you can eventually separate it, so that's physically mixing them together, but it's made up of two things. So let's now look a little bit more specifically into these two categories. So we just talked about what matter is, basically anything around us. Has space, takes up space, and has mass. Then we look at if it's made up of one thing, it's a pure substance. If it's made up of more than one thing, it's a mixture. So then pure substances can classify a little bit more as well. So pure substances we look into, okay, is it separable into simpler substances, or is it just one substance? Elements are pure substances that cannot be broken down. And compounds are pure substances that can be broken down through chemical changes. So it's still pure, it's still made of one type of thing, but one can be broken down, one cannot. So aluminum from an aluminum can is only made up of aluminum atoms. Sodium chloride salt, for example, or water, is made up of a compound, NaCl. So this can be broken up into sodium and chlorine. Therefore, it's a compound. It's still pure, though, because that's all you have in salt. It's just NaCl. So then we look at a mixture. So a mixture can be uniform, so you can't really see that it's a mixture, or not uniform. So a homogeneous mixture is also known as a solution that's uniform composition. So it's uniform throughout. So for example, vanilla ice cream or Kool-Aid, or even your coffee with your sugar, a cappuccino, some kind of a drink, those are all homogeneous mixtures. They're made up of different ingredients, but we can't physically see them or separate them. Heterogeneous mixtures is a mixture where the composition varies from point to point. So for example, vegetable soup, right? You can physically see it varies from point to point. Rocky Road ice cream, oil and water is a heterogeneous. You know that the oil would float on water. So here's just all of that put together. We know what matter is. It's all around it. That's what we're focusing on in our studies. And we say, okay, does it have a constant composition and properties? If yes, it's pure. It's a pure substance. Then can it be broken down further? No. Element? Yes. Compound. Mixture would be if it's made up of more than one thing. It does not have a constant composition. Is it uniform? Is it completely mixed together well, uniform throughout? You don't see how it varies. Homogeneous mixtures. If you do, heterogeneous. Now, last little bit here is just to go over how to actually separate certain mixtures. So, first method is called decanting. So this is for separating mixtures. So mixtures are separable because the different components have different physical and chemical properties. Based off of what these mixtures are, we can use different methods to separate them. Now, a mixture of sand and water can be separated through decanting, which just means pouring over. You wait until all of the sand, all of the solids sinks down, and then you pour over to another beaker or something, the liquid, to then separate the two from one another. Another way to separate a mixture is through something called distillation. So this is when you have a homogeneous mixture of liquids. So it's two liquids together, and you actually can't see the difference of the two liquids. And the way that we can separate them is through the difference in boiling points. So the decanting would be for a heterogeneous because you can physically see the difference of the solid and the liquid, and we pour the liquid out. When we have two liquids, like a drink, you don't see the difference of all the different liquids that are in it. So what you do is you do distillation because it separates the liquids through boiling points. So what happens is you have this mixture of your liquids and you add heat and it begins to boil. So the liquid is heated to force the components into a gas phase. So when liquid, just like when you boil water, it turns to steam. So we boil this liquid and it turns into gas. So then what happens is these gas particles are in this condenser. And the gas is condensed back into the liquid form and then collected. So the one with the higher boiling point is what's then collected over to another flask through the evaporation. Another method of separating mixtures is through something called filtration. So when a mixture is composed of an insoluble solid, so something that doesn't dissolve, and a liquid, it can be filtered. So again, something that you can actually see isn't dissolving. You can just collect the solid or the liquid by having a funnel and pouring the mixture with the solid into the funnel, where then you can just collect the liquid and the solid would just be in the funnel itself. but not least is chromatography. Also a method of separating mixtures. So this can separate different components of a liquid mixture. And the way that it separates them is through the different masses. So you have this strip, and this strip is placed into some kind of a reagent. And what that will do is when you take a dot, an ink spot, and water level, you then dip it into your mixture. And the water level, based off how this will act with your mixture, will separate each of the components in that mixture by their mass. So then you can see this will be one, this will be the other, and this will be the other.